Our next big topic is the atom and radiation, and we'll finish off with a little bit of fission and fusion. It's quite a big topic. It is an important one. It's almost always the last question in your Module 1 paper. We start off by looking at the history of the atom and how we know the things we know about the atom. If you do chemistry, you're going to find bits of this topic very, very easy. If you haven't, that's okay. We don't assume that you've done chemistry, and we will teach everything from the very, very beginning. So we're going to go back in time to start this off to Greece. And a very clever person there came up with the idea of the atom. And how he came up with this was he watched sand pouring out of a container. And if you have dry, fine sand pouring out of a container, it looks like it flows. So he came up with this idea that, well, that looks like the way water pours out of a container. And if sand does the same thing, and if sand's made up of lots of these tiny little discrete particles, maybe that's also true of every other material. And he came up with this theory that if you took a block of wood and chopped it in half, and then chopped that in half, and then chopped that in half, and then chopped that in half, you're going to get the smaller and smaller and smaller bits of wood. And what he proposed was there are two options here. Either you can keep doing that if you had a small enough knife forever, and you just keep on getting smaller and smaller bits of wood, or else there would come a point where you get down to the building block of wood, something that would be indivisible, and that's what the word atom means. So he came up with this idea of atoms. It was largely forgotten about for a very long period of time after that. This guy got some things right. He said things like he considered them all to be little balls like this, and they were all had different shapes. So he didn't get everything right, but one of the things he said was things like iron have little hooks on them like this, and because they then can hook onto each other, that is what keeps them very, very strong. Atoms of other things, like he said, the atoms of lemon juice have little spikes on them, and that's what makes them so sour in your mouth. So while the idea of atoms was good, he didn't get everything right. There was other ideas back then, which was that things are made up of elements, not the elements you would have learned about in chemistry, but the elements earth, wind, fire, and water. And things like trees were made up of earth and water because that's what they grew from. And different things mixed up with these different four elements is what produces everything, all the materials around you. And that idea actually won out and was believed right up to about the 1600s or so. But eventually we were able to do other experiments that proved that the atom existed. Okay, now that's not what we're looking at here. We're looking up at what the atom is made up of. Now, for a long time then, people did think the atom was exactly what the word atom meant in Greek, that it was indivisible. And we do kind of think of it in our heads as being these solid, tiny little, almost snooker balls or something like that. But then a very, very famous scientist called J.J. Thomson came along, and what he did was he did little experiments on metals. And he was able to do this experiment where he was able to detect this tiny little particle that came off that metal. And he was able to make very precise measurements on it. And the measurements he did told him it was much, much lighter, much less massive than an atom. And it also had a negative charge. So he would have done this for, say, copper. And he then would go away and do the same experiment for iron. And what he found out was he got exactly the same particle off it, no matter what material he used, no matter what type of atom he was using, he got exactly the same tiny little particle coming from that. And he deduced, well, okay, if that's coming from all these different types of materials, it must be a part of the atoms. That must be where it's coming from. But what they knew was, draw that a bit bigger, he knew these atoms were neutrally charged. Okay, and he had a problem because he discovered this tiny little particle that came from the atom. So what he said is, okay, these particles, which eventually became known as electrons, are just dotted kind of randomly through the structure of the atom, like so. Okay. However, if we look at there, I've drawn them as little red dots. We have 1, 2, 3, 4, 5, 6, 7 electrons there. And the problem he had was he knew that 7 electrons would have a charge of -7 because each of them has a charge of -1. He knew it was neutrally charged, so all he did was he said, okay, well, the entire rest of that sphere of the atom must have a charge of +8. plus 7, to make it overall neutrally charged. Okay, because he knew that it was neutrally charged. Now you may think, why did he not come up with this idea of like a positive particle that could cancel out those electrons? There was no evidence for it. So he came up with what is known as the plum pudding model of the atom, and you can see there's a little diagram in your notes. Plum pudding model, you can think of it a little bit like a Christmas pudding. Okay, you have a sponge and then you have these raisins and currants dotted through it. Okay, so he said plum pudding model consists of a positive sphere of charge with these tiny little negative electrons kind of positioned randomly or distributed randomly through it. Okay, however, this is a theory. Everything in science is just a theory. If we want people to believe our theories, we need evidence to back it up. So this is a perfectly good theory because it fitted with all the evidence that had come beforehand from the experiments. But then you need to make predictions using this, test it, see if those predictions are true, and then you have a weight of evidence to make people believe your theory. And we're going to look at the experiment in the next video.